Okay, welcome back everybody to Proving Triangles Congruent. Today we're going to learn 3 new techniques to prove 2 triangles congruent. We already know 2 from the previous video. The previous 2 were SSS, or side, 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 and SAS, side, angle, side. And so we're going to learn 3 new ones today. So first of all, though, we have to go through some vocabulary. We have to know what does it mean to have an included side of a triangle. So the definition of an included side is the common side of 2 consecutive angles. So if you look at this drawing we have here, we have 2 consecutive angles that are angle P and angle Q. And those 2 angles have a common side, which is side PQ. So we would say that side PQ is included between angles P and Q. The first of our new theorems today, actually this one's a postulate, is called the angle side angle postulate, abbreviated as ASA. And it says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So if you look at the 2 triangles there, you see triangle ABC and triangle DEF. I've marked off angle A and angle D as congruent. I've marked off angle B and angle E are congruent. And I've marked off the included side AB is congruent to the other included side DE. So if we look at the 2 triangles here, we have angle, side, angle in the first triangle, angle, side, angle in the second triangle. And so we can draw the conclusion that these 2 triangles are congruent by angle, side, angle. Okay. Let's do an example with that new postulate here. So we're trying to prove these 2 triangles congruent, the triangle on the left and the triangle on the right. We're given that the 2 upper angles are congruent, so angle UXV and angle WXV are congruent, so I have that marked off. You're also given that the triangle on the right has a right angle, which you see marked off as well. So what do we know? Well, we know that this other angle right next to that right angle has also got to be a right angle because those 2 angles add up to a straight angle. They're a linear pair. So if one's 90, the other's got to be 90. They've got to add up to 180. We also know that the 2 triangles share a common side, so that's really a side in both triangles. So now if you look at this drawing here, you can see that those 2 triangles are congruent by angle, side, angle. You can just follow what we're saying there. Angle, included side, angle. Likewise, in the other triangle, angle, included side, angle. So we can conclude that those 2 triangles are congruent by angle, side, angle. Okay, so the second of 3 new techniques we're learning today to prove 2 triangles congruent is actually our first theorem. Those first 3 ways were actually postulates. So we're going to prove this one. This one's called the angle-angle-side theorem, or it's abbreviated AAS. And it says if 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle, then the triangles are congruent. So if you look at the 2 triangles I have in my drawing there, we're trying to prove those 2 triangles congruent. So we're given that angle A is congruent to angle D, and we're given that angle C is congruent to angle F, and we're given that side BC is congruent to side EF. And so you can see we're given that you have 2 angles on a non-included side of this triangle congruent to 2 angles on a non-included side of this triangle. So we're trying to prove why that's actually true, and we can't use the theorem to prove itself, so we've got to use a different technique here. So notice that we can now conclude also that angle B in the first triangle is congruent to angle E in the second triangle because of the third angles theorem. Remember that one? If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So we've used that one already. Okay, now if you look at the 2 triangles, you can now say that they're congruent because look, you have angle, side, angle. Likewise in the second triangle, angle, side, angle. So you can use angle, side, angle, which was the one we just proved just a minute ago. Actually, it was a postulate. Is going to help us conclude that these 2 triangles are congruent by angle, side, angle. Okay, so the final way, so this is going to be the 5th way to prove 2 triangles congruent. It's called the hypotenuse leg theorem, and this one only works when you have a right triangle. And what the hypotenuse leg theorem says, and it is provable, but we're not going to prove it today. It's going to be proved later in the course. But what the hypotenuse leg theorem says, which is abbreviated HL, it says if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so this one again can only be used when you're trying to prove two right triangles congruent. So again, we're not going to prove that, but we are going to use it in our example here. So if you look at the diagram that I have up here, we're trying to prove triangles. I'm going to highlight these so you can see them better because you got a whole jumble of triangles in there. Triangle VWX. So triangle VWX, trying to prove this triangle. Now forget that little yellow artifact in there. I'm trying to prove that triangle congruent to YXW. So this one. Okay, so we're trying to prove them congruent. So what do we know about those two colored triangles? Well, we know that they both have a right angle, so that means they're right triangles, and they both have a leg in common. Remember, the leg are the two legs of a right triangle are the ones by the right angle, and the hypotenuse is across from the right angle. Okay, so what we also know about those two colored triangles is they have a common hypotenuse. So if they have a common hypotenuse, that's going to be considered congruent, a congruent part of both of those triangles. So we can conclude, if you look at the two colored triangles, that they are congruent by HL, hypotenuse leg, because number one, they're right triangles, otherwise you could not use that theorem. And number two, they both have a leg, that's the L there in HL, they have a leg congruent. You can see that marked off with one tick mark. And they have their hypotenuses congruent. You can see that with a double tick mark because they share that same hypotenuse. And so you can say those two triangles are congruent by HL. All right, so that's all you need to know. Let me summarize briefly what we learned in this lesson. We learned 3 new ways to prove two triangles congruent. That makes us a total of 5. Earlier we had SSS and SAS. Now we have ASA, AAS, and HL. AAS says if two angles on a non-included side of one triangle are congruent to two angles on a non-included side of another triangle. ASA says if two angles on an included side of one triangle are congruent to two angles on an included side of another triangle, then the two triangles are congruent. And then HL, which remember can only be used for right triangles, says if the hypotenuse and leg of one triangle is congruent to the hypotenuse and leg of another triangle, then those two triangles are congruent. Okay, that's all we have. There's a couple of assignments posted, so let's go ahead and get started and enjoy.